So number 1 here, we have two equations that are both equal, meaning the left side of the top equation essentially weighs the same amount as the right side of the top equation. The left side of the bottom equation essentially weighs the same amount as the right side of the bottom equation. So what we have here are two balances. Now, if I had a scale with a certain amount of objects on one side and a certain amount of weight on the other, and it balanced, I can change the weight of either side of that balance as long as I change it in equal portions on both sides and it remains balanced. Well, with equations, all we care about is that it's balanced. We don't care how much weight is on either side. And we frequently change the amount of weights to boil it down to where we get something like x equals 5. So if you have two balances, you can add everything on the left sides together and everything on the right sides together, and the equations will remain balanced. And the nice thing about doing it in this case, if I just simply add these two together, the x's turn out to be 0, and then I get 6y equals negative 36. And I have eliminated one of the variables. The reason it eliminated is because it was the same number with different signs. And that's what we're going to try to either find or create today. So now I go ahead and divide by 6, y equals negative 6. That is the first half of my answer. To get the second half, I just plug that in. So negative 4x, negative 2 times negative 6 is plus 12 equals negative 12. Subtract 12. Negative 4x equals negative 24. So x would be 6. And I'm done. If things are set up nicely, elimination is usually pretty easy, but elimination can get kind of messy. So if we look at number 3, is it set up for elimination? Yes. I could add those and the y's will cancel. But if you look at number 5, it is not set up for elimination. If I were to add this together, I'd get negative 6x, negative 18y, and negative 48. And that's still a true statement, but all I did was made a more complicated equation that still has two variables. Could I alter this so that it will eliminate? Times either the top or the bottom by a negative. And in this case, it looks like it doesn't matter because everything's negative. So if I times the top by negative 1, that will turn all of these positive, and now my y's cancel. Negative 2x plus 4x is 2x. Negative 25 plus 23 is negative 2. So x would be negative 1. Now I take that negative 1 and I put it back into either equation for x. So 2 minus 9y equals negative 25. Subtract 2. Subtract 2. So negative 9y equals negative 27. So y equals 3. I'm done. Is this all coming back to you now? Yeah? Okay. What about number 9? Nothing lines up in number 9. So now I need to add weight to one of the sides until something's going to cancel. I could times the top by negative 2, in which case this would become negative 10 and they would cancel. And when you times it by negative 2, you multiply everything by negative 2. What else could I do? I could times by 7, the top by 7, and then the y's would line up. And in either case, it's going to work. Okay? So on number 11, what would you do? Times the top by negative 3, and then the x's will cancel. Okay, and the only other reminder is like number 21. On number 21, does 3 go into 5? No. Does 4 go into 6? No. So if I can't even multiply one of the equations to make it work, how would you do it? You need to times both of them together by something so that you create a number that will cancel. So first we need to pick x's or y's. And it doesn't, in this case, it doesn't matter. So let's focus on the x's. Can I multiply the top x and the bottom x by two different numbers so that they will cancel? If I times the top by 3 and the bottom by 5 won't work because it will make two 15s. -5. So this would give me 15x plus 12y equals -14. And then -15x minus 30y equals -30. And now my x's eliminate. And then you just solve from there. Oh, thank you. So 14 times 3 is 52. -52. Now it'll work. When I get my answer, y equals, I probably don't want to plug them in here, although it would work. You probably want to take this number and plug it back into one of those. All right? Get to work. Good luck.